All right, so today, more applications with logs and exponents with the exponential growth and decay model, decay model. So remember this formula, A of t is a function in terms of time. So A of t is the ending amount, P is the principal, R is the rate of change, could be positive or negative, and T is time. So time can be years, months, days, whatever. Okay, so just as a quick going over, because it actually is one of the more important things that I go through in reference to Mr. Regents. The following formula to answer the questions where T is the number of months. So it's a function of time. T here is months. So is it growth or decay? Well, according to this, remember we do 0.78 minus 1. It's negative 0.22. So it's 22.0% negative. So it's 22.0% decay because we know this is negative. So we know this is a decay formula. If the base and T is, if T is all by itself up here, meaning there's no number on it or anything, and we can just look right here. If the base is greater than 1, it's growth. If it's less than, it's between 0 and 1, it's decay. So the initial amount of invested is this number right here, 3,500. Now we always look to see if they say in hundreds and thousands. So sometimes you may have to change that, what you have. What is the percent rate of change? Oh, look, I did that here. So it's 22% rate of change. And it is negative, but it's negative when we're dealing with is it growth or decay. Oh, crap. All right, for this one, is it a growth or decay? Well, you see that this thing, that 1.35, it's greater than 1. So you know that it's going to be growth. But the way to figure out, it's 0.35, so it's positive. So that means that it is growth. Using that, we know we move that over 2 decimal places. So it's a 35% change every decade. Okay, so since this was in decades, it's a change per decade. What is the initial amount invested? 2,735. It doesn't say hundreds or anything, so that's it. So now using the formula here, we have to sometimes put the formula in ourselves. David bought a new car at cost of $35,000. It depreciates approximately 1% every month. So we need to write a formula that would show David's car, what David's car will be worth over a month. So you can name the formula whatever you want. So C of M. All right, and then remember it starts with the principal amount goes first, so that's 35,000. And then it's 1 plus, oh, no, it depreciates. So since it depreciates, it goes down. So note to self, depreciate means that R is going to be negative 0.01. So remember when you have 1%, the dot is there. We move it over 2 decimal places to put it into the formula. So you always, R always has to be a decimal. R must be a decimal. R must not a percent. It's a decimal. So move it over 2. If it depreciates, that means it goes down, so it'll be negative. Okay, and then will be worth over months. So since it's C of M, this and this should match. So there's my formula to determine how much the car will be worth after 3 years. So this says years, but I'm in months. So how many years, how many months are there in 3 years? Well, that would be 36. So M is 36, and we simply plug it in. So C of 36 is equal to 35,000. And then that would be, 0.9 to the 36 months. So remember, make sure that this has to match this. So If it's months, then you have to convert it to months. So just simply type that into your calculator and see what you get. So after 3 years, approximately, the amount of time, money that it's worth, so it's 24,374.46263. Okay, since I didn't say where to round, this is what you have to do. So that's how much it's worth after three years. So this one actually tells you kind of how long will it take to the nearest month for the car to be worth 10,000. So this is more like Algebra 2. This one is more like Algebra 1. So we want the car to be worth 10,000. So remember, the car's worth, that's the C. So this is our formula here, C of T. In our case, it's C of M. And it started at 35,000. And 0.99 to the M. So 10,000 is this. When is it worth? So we are going to be solving for an exponent. So remember, anytime you solve for an exponent, you know that logs will be involved. Please know logs are involved. Solving for exponents, use logs. Please, God. Okay, so to solve this is why we spend time solving these on our own without the word problem, so this wouldn't be an issue. If you multiply that in, I will disown you. You must divide first. Remember, you can't multiply this in because this has to be done first. Exponents are always done first. So if you can't do an exponent, you can't multiply it in. So here we divide.